Okay guys, so let us start. Now we already know that when current flows in conductors, it produces its own magnetic field, fine. But now when we already have some magnetic field which is present and then a new magnetic field is also present, then the two magnetic fields interact. And the moment they interact, they give rise to something called as the magnetic forces. So magnetic force is because two magnetic fields have interacted with each other. Is that fine? So how does it happen and what all is to be discussed? So I will be taking with the examples. See, the first concept that we are going to discuss in this unit is the magnetic force on a charged particle which is moving in a uniform magnetic field. Fine. So we already have, for example, this space, it is already occupied with magnetic field. So it has magnetic field. Now what I am doing is, I am bringing a charge and putting it into motion. So when a charge is in motion, you know that it generates current, isn't it? So that charge will also generate its own magnetic field, isn't it? So the two magnetic fields interact with each other. And the moment they interact with each other, what happens? Force gets generated. That force is called as the Lorentz force. What is it called? Lorentz force. Okay? And this Lorentz force is the reason that this charge, changes its path. Fine? The magnitude of this force is given by the charge times V cross B, the velocity cross product with the magnetic field. Okay, so here try to understand what I am trying to show you. See, we have a magnetic field here. The direction of the magnetic field is like this. Okay, this is the magnetic field. This is the plane I am talking about. The velocity of the charged particle that we have is this. Okay, this is the velocity of the charged particle. Fine. And the angle between the two is theta. Fine. Is that clear? So we have magnetic field here. B is the magnetic field which is already present. V is the velocity of the positively charged particle which is moving at an angle of theta with respect to the magnetic field, but it is in the same plane. Very important.
Q.
Yeah?
What is Q?
Q is the charge. The charge that is moving. Fine. The positive charge. Fine. So remember, this charge which is moving with some velocity in this direction will experience a force called as the Lorentz force, and the expression for that Lorentz force is Q times V cross B. V cross B is magnitude of V times magnitude of B times the sine of the angle between the two. Very important. The sine of the angle between velocity and the magnetic field. So velocity is here, magnetic field is there, the angle between them is theta, fine? So you need to know this angle, you need to know the velocity, you need to know the magnetic field and the charge. Multiply all of them, you will get the force, fine? That is the magnitude of the force.
Isn't the formulas the same?
These formulas are same, yes. Now this cross has been replaced by sine of theta. A cross B is AB sine theta, right?
This is not times.
No, this is not times. Hello, this is not times. This is not V times B. No. This is V cross B. This is the product, the cross product of vectors, which has to be written as V times B times sine of the angle between the two. Is that fine? Clear? So that is why this is the formula. The magnetic force is given by Q times V times B times sine of theta. This is not times, this is cross product. When you multiply two vectors, you can multiply them in two ways. Either you multiply them by dot or you multiply them by cross. This is not times. This is the cross product of two vectors and this is the dot product of two vectors. Fine? Now because force, it is a vector quantity, therefore this force has direction, isn't it? Now in order to understand the direction, there is a rule. The rule is the right hand rule. So what you have to do? Understand, very important. First of all, you need to understand that the direction of the force is always perpendicular to the plane. Force is always what? Force is always perpendicular to the plane of velocity and magnetic field. Very important thing. Force is always perpendicular to the plane of velocity and magnetic field. That means if this is the plane, the magnetic field is like this and the velocity is like this, but both are within the plane. The force which the charge will experience will either be like this, perpendicular, or it will be like this. Isn't it? So now we have to understand what is the direction. Is it this or this? Because both are perpendicular. So force is always perpendicular to the plane. How do we find the direction? We use the right hand rule. Now what is the right hand rule? Understand, very important. What you have to do is, you have to start from V and go towards B with the help of your right hand. So what you do? See. Start from velocity, use your right hand, curl your fingers from V to B. From V to. So here, velocity is here, isn't it? And then you have to curl your fingers towards what? B. When you curl your finger, what is happening to the thumb? Thumb is going up. That is the direction of the force. Is that clear? Is that clear?
Is that B or B or?
What is that?
F is perpendicular to the plane of V.
To the plane of V and B. Both. So this is the magnetic force. Understood? So you have to use your right hand, curl your fingers from velocity towards the magnetic field. The direction of the thumb is the direction of the force. Khalas. Is that clear? Is that clear? So you will understand where will this charge go. Now, when the charge was trying to go like this, in this case, it was trying to go like this, the force applied on the charge will take it up. Is that fine? The charge will go up. It will not be able to go forward in this direction. The force, the magnetic force, the Lorentz force will compel it to go up. Is that clear? This is the concept. And this is the expression. So you have to know the expression. You have to know the direction. That is important. Why is this happening? The reason is, this charge actually generates its own magnetic field. There was already some magnetic field. The two magnetic fields have started to interact, and when they interact, they give rise to a force called as the Lorentz force, whose value is this, whose direction is this. Khalas. Clear? No problem in this? Now see. This is the way you have to go for the direction. This is your right hand. This thumb will give you the force. But how do you find that force? Start from V and go towards B. Start from V and go towards B. This thumb will give you the direction of the magnetic force. Is it clear? Every time. Fine? No problem in this? Okay, but very important thing, that force is always perpendicular to velocity. It is always perpendicular to magnetic field. Very important thing about this magnetic force. Clear? Fine? Now here we have some questions where we have to find the values. Okay, the direction of the force. The first case is when the magnetic field is inwards and there is a positive charge which is going like this. So if I ask you, what will be the direction of the magnetic force? Can you tell me? Can I have one more pen? Okay, I have this. So, understand, very important. What is the direction of the magnetic field? Inwards, that means it is like this. What is the direction of the velocity? What is the direction of the velocity? Here? Isn't it? The velocity is right, towards right, isn't it? So this is the velocity, right? So now, you have velocity there and you have magnetic field inward. So what do you have to do? Use your right hand. So when you use your right hand, it will go like this. Yes, khalas. So that means the force will be up. Is it clear? Is it clear? Fine? Now talk about this. Talk about this. Which charge is moving? Negative charge. Very important. Let me come back to the previous concept. This force, the direction of the force with the help of right hand rule, is only valid for positive charges. For what? For which charges?
Positive.
So that means if there is a negative charge, find the direction of the negative for the force, but the actual direction will be opposite. Is that clear? So when positive charge is there, you'll be using the right hand rule to evaluate the direction of the force. But whenever there will be negative charge, the direction will be opposite. Okay, I'll write it down. For negative charges, direction is reversed. Very important thing. Fine. The magnetic force on a positive particle is in the direction you would push your palm. That is for the positive. But for the negative, it will be always what? The reverse. Fine. So let us come to this problem again. Now, here in this case, can you tell me what will be the direction of the magnetic force? Yes. Understand. What is the direction of the magnetic field? Magnetic field is up. Isn't it? What is the velocity? Velocity is there, isn't it? So we take velocity. Velocity is there. Fine. So we keep velocity like this, magnetic field like. Is this the combination now? So we have to start from V and go towards B, isn't it? So we have to start from V and go towards B. What is the direction of the thumb? No, for this board. Inwards, exactly. But is the actual force inwards? No, the force will be outwards. Why? Because this was not a positive charge, this is a negative charge. Is it clear? Is it clear? The right hand rule is only valid for positive charges. We cannot apply it to negative. So whenever there is negative, apply it to negative, but the actual direction has to be found by reversing the direction that you obtained. Is that clear? Is it clear? So V cross B, start from V, go towards B, thumb will give you the direction. So whenever in this case V was here, magnetic field was up, so we go like this, it shows us inwards, but the direction will be outwards. Why? Because this was a negative charge. Is that clear? Okay, now we talk about this. Anyone? Where is the magnetic field? Where is the magnetic field? It is there?
Yes.
Where is the velocity? Here, isn't it? Isn't it? What will be the direction of the force?
Down.
Yes? This is the case. Magnetic field is towards, and velocity is here. This is the case. So we have to start from velocity, isn't it? And then go towards. So is it like this? What is the direction? Inwards, isn't it? We will say it is inwards, right? Correct? Yes? No, this is wrong. Why is this wrong? Very important. Can you tell me what is the expression for the force we just said? Yes? Force is equal to what?
Something.
Charge, what was moving, times velocity, times magnetic field, times sine of what? The angle between the velocity and the magnetic field, is it? Now, Fatima, tell me, velocity is here, right? Magnetic field is there, yes? Isn't it? What is the angle?
180.
Very good, 180 degree. So sine of 180 is? 0. When the sine of 180 is 0, it means the force will be? Oh, come on, we were trying to find the direction of something which does not exist. So there is no force. We don't have to find the direction. Is it clear? That is why inverse is not correct. There is no force. Why? Because, so understand, whenever theta, remember from today onwards, whenever theta is 0 degree, because sine of 0 is 0 and theta is 180 degrees. In these two cases, the force applied would be always 0. There will be no force. That means when there is no force, the velocity of the particle will remain constant, isn't it? The acceleration would be what? 0. There will be no acceleration because there is no force. So in this case, when the particle is parallel or anti-parallel, that means the angle is either 0 or 180 degree, the force doesn't apply. So you don't have to use the right hand rule to find the direction. Is it clear? Okay, now come to this case. Come on, tell me. The magnetic field is here, the green one. The velocity is up and it is a positive charge. Tell me what is going to happen. Yes? This is the velocity, this is the magnetic field. So this is magnetic field and this is the velocity. Come on, tell me. It is like this. From V to V to B. V to B. V is there. Cross B. Understood? Point your fingers along V. So it starts from V and then go towards B. When you go towards B, thumb is going inwards. So the force will be inwards. Is that clear? Is it clear? Fine. So this is the concept. Clear? If you want, see, now sometimes it feels very difficult to use your right hand rule. So I will give you a trick to find the direction without using the rule. Fine? You just have to understand the concept of the product of vectors. So the first important thing I told about force is that force is perpendicular to velocity and the magnetic field. You understand this? Isn't it? So then I told you that force is equal to Q times V cross B, right? Is it? So I will tell you how to find the direction without using the rule, without using the right hand rule. See? Do you know yesterday I talked about 3 unit vectors. One was I, the other one was J, and the third one was K. Did I? I is used along positive x-axis. J is used along positive y-axis and K is used along positive z-axis. Is that fine? So that means when you go in the opposite directions, what will be the values? Yes? In the opposite directions, this will be negative K, this would be negative J, and this would be what? Isn't it? So from today, understand the rule. The rule is this. If you are asked I, J, and this is K. See, understand the rule. If you are asked to go from I cross J, if the direction starts from I and goes towards J, then the answer is always K. Fine? When you are asked to go from J to K, the answer is always. When you are asked to go from K to I, the answer is always J. So when you go in the cyclic order but clockwise, all the answers are positive. Is it clear? Is it clear? When you go from I to J, answer is what? K, and you can understand what is K. K is outwards, isn't it? If you are asked to go from I to K, what will be the answer? If you are asked to go from I to K, the answer would be, it is the reverse, isn't it? The answer would be J, but negative J. Clear? So in this direction, it would be negative. If you are asked to go from J to I, the answer would be negative K. So anti-clockwise, counter-clockwise direction is negative. Is that fine? Is that fine? So now if I apply the same rule here, where is the magnetic field? Inwards. Inwards is negative K, isn't it? Where is the velocity? I. Right? So here what I am doing is I have to start from I and go to negative K, isn't it? I have to start from I and go to negative K, right? So let us come to the concept. I have to start from I and go to negative K. Now let us apply the rule here. Where is I? So from I to K, answer would be? No. I to K, it is the reverse. From I to K, answer would be negative J. So from I to K, answer would be negative J. But this is negative already. Negative and negative is? Therefore it is positive J. Positive J is up. Understood? That is why you said force is up. Is it clear? We did not use the right hand rule. We are just using the understanding of the cross product. Fine? Now see here. What is the velocity along which direction? Negative? Very good. So it is negative I. Cross with what? velocity to B. B is J, right? So what is the answer? What should be the answer? It should be I cross J. Now let us come to the concept. I cross J is positive K, isn't it? This is positive K. But this is positive K. But because this is negative, so negative will be here, right? Negative K means inwards, correct? Isn't it? But this is which charge? So it is not inward, it will be outwards. Khalas. So answer came out to be negative K. So you have to reverse it. After reversing, you will get plus K, isn't it? Clear? Here, see now what is happening here. What is the velocity? Negative I. What is the magnetic field? I, isn't it? So it is from negative I to, now this is always 0. So there is no force, there is no direction. I cross I is always 0. J cross J is always 0. K cross K is always 0. Is that fine? Understood? Clear? So there are two ways in which you can evaluate the forces. One, simply understand the rule, the cross product rule, or simply go with the concept of the right hand rule. Is that fine? So it will be easy for you to evaluate. Now there is a numerical, try to solve this question. That's it? Okay, take this as a homework, maybe tomorrow inshallah we'll do it. Fine? Thank you.